Okay, so this I'm calling notes 5.3b. It's just a continuation of how to solve trig equations, but now we're going to look at some more complex equations. That first bullet point that I have here for solving trig equations, to isolate the trig function and solve. I mean, essentially, we already did this on Friday or in our intro. So that question that Hannah asked about on the homework assignment, we were isolating secant x. We had to add 4, divide by 3, we had a square root. We had to get secant x all by itself so that we could answer. If you can't just isolate the trig function, if it's not that cut and dry like we're going to see today, I have a list of things you can look for or things that you can try. So you might try substitution with a trig identity. This is really useful when you have like different trig ratios or functions in the same equation. You can't really solve an equation that has a sine and a cosine in it. You'll have to have it all in sines or all in cosines. So you might make a substitution. You might try factoring. So factoring is a solving method that was introduced to you way back in Algebra 1, and then you really hit it hard in Algebra 2. And we use factoring to solve. The first time we learned about factoring to solve is with quadratics. So you're going to learn to like factor when you see things like you might have a sine squared x and then you also have a sine x term in the same equation. Those aren't like terms. You're never going to get them to add together, so you're going to have to get them on one side and factor. So that's a good signal to you to use factoring, is if you have one trig function that's squared and one that's not. The third one, combine like terms, we actually did one like that on Friday in our notes. We have one example where there was like a sine x on the left, and there was a negative sine x on the right, and we needed to group them together, so we added sine x to both sides, and we got 2 sine x. So you might have to combine like terms in order to be able to solve. And then the last thing that's up here is just to remember that there are different ways that your answers will be represented. And I get a lot of people who, each year are really confused about, like, how do I know when to answer with that plus the period times n? Those represent your complete solutions. And anytime your directions, like the directions on the weekend, just said, solve the equation, we assume it means all the solutions. And we know because of coterminal angles that there are infinitely many solutions, infinitely many angles that work. So we have to write that complete solution. The only time we don't have to do that is really when the directions say something about answering between 0 and 2 pi. If you have to answer between 0 and 2 pi, just make sure you have all the angles that will work that fit within one revolution of a circle. So directions are going to be key. Let's solve some equations. Now, if I'm paying attention to the directions, it just says solve the equation. So I'm thinking about at the end of this, I'm going to want a complete solution. I'm going to be adding the period times n. All right, when I look at the first equation, 2 cosine squared x equals cosine x, I see that I have 2 different types of cosines, one that's squared and one that's not. No matter how hard I try, I'm never going to get those 2 cosines to add or subtract together. So I think in a case where I have a cosine squared and a cosine, I'm going to have to factor. In order to factor, one side of your equation has to be equal to what? 0. Okay, always remember that. That's not something new that I'm telling you. That's something that's true since Algebra 1. One side has to be equal to 0 in order to be able to factor. Now, I'm going to put out a little warning right here. Some people might have looked at that problem at the very beginning, and you can even look over at the other side and think, well, what if I just divide? Like, I could divide by a cosine, and then the other side will be equal to 1, and then I'll just have a cosine x on the left. The problem with that is the same as what was true in Algebra 2. If you divide by x, your variable, a solution of yours is just disappearing, x equals 0. It's gone. And if you divide by it, you're probably not going to remember to write it down. So don't divide by a cosine, don't divide by a tangent, don't divide by any of the trig ratios, because then that solution, cosine x equals 0, off to nowhere, and you're missing those solutions. So instead you want to factor. Now that we got them on the same side, both terms have cosine, so I'll factor out a cosine. Remember, if you divide by cosine, you'll be missing this factor. And that will be sad. You won't have all the answers. What do you do after you factor? How do you solve?
Set each one equal to 0.
Perfect. Thank you, Liam. I think you're the first person today to get that right away. Good work, 4th hour. Okay. All right. Cosine x equals 0 and 2 cosine x minus 1 equals 0. Again, I'm not changing the rules of the game. If you're solving by factoring, you factor, then you set your factors equal to 0. Your factors just happen to look like trig ratios or trig functions. Now we can answer. And remember, we're going to be answering with complete solutions, so we're going to be adding our period times n. Can you think of any angles that have cosines of 0?
0.
Well, to go to 0, I would go right 1, so my cosine would be 1.
Pi over 2 and 3 pi over 2.
But you're on the right track. It's those quadrantals, right? They're just the quadrantals on the y-axis. Whoa, that would have been looking away there. Pi over 2 and 3 pi over 2. Okay, and then I'm going to add the period times n. What's the period for cosine? 2 pi. Okay. Now, you might see, and this will be true especially if you're checking answers in the back of the book, that actually those answers could be condensed, because pi halves and 3 pi halves are really just pi away from each other. There's a difference of 180. So this answer can be condensed to just say pi halves plus pi n. Because if I add 1 pi, then I'll be at 3 pi halves, then I'll be at 5 pi halves, then I'll be at 7 pi halves, and I would just go through. I'll accept either answer. So some people will see that real clearly right away, and some of us would just write down this full answer, and that's fine. So if your answer seems to have more than what the back of the book has, you might think about like if they tried to condense it. Okay, and then we have to do the other factor, right? This will be cosine x equals add 1 divided by 2, 1/2. Those angles are pi thirds and 5 pi thirds. And add my period times n. Now, those are not a difference of 180 or pi. Right? One's in quadrant 1, one's in quadrant 4. So they have to be separated. That answer doesn't condense nicely. So that would be our only way to write that. Okay? Questions, concerns? All right, I want you and your pods to work on solving 3 tangent cubed x equals tangent x. Can you talk each other through it? What are you going to do first?
No way. factor. I'm not sure what to do. Zero.
Okay, I've worked it out up to my factoring and setting the factors equal to 0. So as I'm walking around, I think most people are doing this correctly. Don't divide by tangent because then you'll be missing that solution. Okay. So factor out a tangent. Since it was a tangent cubed on that first term, we now have a 3 tangent squared minus 1. And then, of course, we just set the two factors equal to 0. Well, now you're at the point where you really just want to solve the factors. For this first one, do you know any angles where tangent is 0? 0 and pi. Okay, so we can write x equals 0 plus pi n, which that could also just be written as pi n. And x equals pi plus pi n. You may notice this one is already in there. Like if this was 0 plus pi times 1, then the answer would be pi. So I don't really have to write this second one. You could just write x equals pi n and be good. Now, I'll leave both of them. That's something that it gets easier with time and practice to see oh, those are, I call them redundant solutions because they're already listed. And then, you don't have to write as many things down if you recognize them. But if you don't recognize them, just write the full solution, and that's fine. Now, on that other one, what do I need to do if I have 3 tangent squared x minus 1 equals 0? How will I solve that factor? Add 1, divide by 3, then square root. That's like the one Hannah asked about in the homework. So tangent x equals plus or minus. Anytime in this trig work you do a square root to solve, remember you have to add the plus or minus. What that means, anytime you do that and you add that plus or minus, now all the quadrants work. Because tangent in quadrant 1, 2, 3, and 4 is positive or negative. And you just have to figure out which family of angles, reference angles, butterflies, bow ties around the unit circle has that tangent square root 3 over 3. That's all the pi over 6's. So then I can say pi over 6 plus pi n, 5 pi over 6 plus pi n, 7 pi over 6 plus pi n, and 11 pi over 6 plus pi n. That would be listing all 4 quadrants, but tangent, because it goes positive, negative, it usually has redundant solutions in it. So you could get by with just the first 2, right? These are the only new solutions. If I add pi to pi 6, I get 7, 6. So this answer is already in this group. And same for 11 pi 6. I don't care if you list all 4 or just 2, so long as you have the full solutions. Okay, questions, concerns? All right. Moving right along. Notice Notice I have a change in direction. It says find all the solutions from 0 to 2 pi. So what I know about the directions here is I'm not going to have to do that plus 2 pi n or plus pi n anymore. I just need to find all the angles within one revolution of the circle that work. Yeah. Okay, what's a little bit different about this problem? Similar, it's got cosine squared and cosine. So I'm thinking about doing what? Factoring. Different, it has some extra constant term, right? So that means that when I factor this one, I'm never going to be able to do just that easy factoring of greatest common factor comes out. I'm going to have to factor a trinomial. Remember, one side has to be equal to 0. Sometimes people in this chapter will like try to subtract 2 and then take out a cosine, but you can't factor if it's not equal to 0. So you have to leave 2 on that side. Let's do factor trinomial. Two groups of parentheses. To get my first term, 2 cosine squared x, I must have had a 2 cosine x and a cosine x. My last term is positive, but my middle term is negative, so they must both be minus signs. So the negative times a negative will be a positive. And then what are factors of my last term? 2 and 1 to get 2. Now I have to be careful when I'm plotting this because like one of them gets multiplied by 2 cosine x and one of them just gets multiplied by 1 cosine x. I need them to make 5 cosine x. So you gotta decide, am I gonna do 2 and 1? 1 and 2. 1 and 2. That way I'll have negative 4 cosine x minus 1 cosine x makes negative 5 cosine x. So remember, we did factoring trinomials back in section 1. Now set them equal to 0. Add 1 divided by 2, so cosine x equals 1/2. Can you give me the angles from 0 to 2 pi that work for that? Pi over 3 and 5 pi over 3. Notice I am not writing plus 2 pi n because if I add 2 pi to either one of those angles, it will be over 1 revolution. It will be more than 2 pi. The next factor will be cosine x equals 2. There are no angles, right? The only outputs for cosine are between negative 1 and 1. So it just produces no solution. Don't force something. Don't make magic. Just do the math, whatever it says. Okay. Now, I'm going to have you kind of brainstorm with your pods here for my next equation. What might you be able to do to solve 2 sine squared x equals 1 plus cosine x?
Oh, yeah. Use that. Yeah. 2 times 1 minus cosine x. You subtract 2 and 1 over. No. I love your confidence. It's one of the what? multiply.
Let's factor it. Oh wait, there's it's sine and cosine. You can't really. Can you just factor each side?
And then move it
Or
over.
just the sine?
Oh wait, shoot. No, because then you have a negative. Sorry.
Now you
Move
won't be
over
able
the
to
negative.
factor if
Yeah.
you have like different terms. That'd be like having an x squared and a y.
Well, that's what I would do. It doesn't
So
matter.
then you would, you might
Well, you
rethink
can't
like
subtract
having
it
it
because
as
cosine
straight.
squared cosine.
No, I know. I'm saying move it over.
Oh,
I'm saying
that makes a big difference.
Shouldn't it be 2 minus 2?
Okay, probably an issue that's popping up among the groups. Yeah, it's how to start. Because, you know, we might think about factoring because you have one that's squared and one that's not. But in order to be able to factor, they have to be the same trig function. Like they gotta be cosine squared and cosine or tangent squared and tangent. So that means you might try what tip that I gave you? Substitute a trig identity. Okay, now beware the pitfalls of 1 plus cosine x. That is not a Pythagorean identity. Why?
It's squared.
It's not squared. So you can't really do anything with 1 plus cosine x. You're probably going to look over here at sine squared x. You could do a Pythagorean identity. Sine squared x is equal to
1 minus cosine.
1 minus cosine squared x. So make a substitution. A lot of times a Pythagorean identity is going to be a good substitution for you, but you could potentially be using like a quotient identity. That might also help cancel something out. Now, remember that the 2 is getting multiplied by sine squared, so that 2 actually distributes now to the 1 and the minus cosine squared, so that's going to be 2 minus 2 cosine squared x equals 1 plus cosine x. Now, this is a secret that I've always told everybody, so I'm not really the best at keeping secrets. But if I'm going to factor, I never, ever factor with a negative squared term. That's just like confusing to me. I always think it's easiest to factor if your squared term is positive. So looking at this equation, because now I have a negative 2 cosine squared x, I'm going to move that to the other side. I'm going to move everything to the right. If you want to potentially torture yourself and try to factor with the negative in front, go right ahead. But it usually doesn't work out too well. So I recommend doing it with a positive.
Potentially torture.
Yeah, it's fine.
Some people can do it. Kudos to them, but I don't like to. Okay, now also be careful here. I'm moving the 2 to the other side. This is a positive 2. So 1 minus 2 is negative 1. It's a negative 2 cosine squared, but the 2 in front is positive. Okay, see if you can factor that. So think about in this trig unit, before you start factoring, you want them to be of the same trig family, so like all sines, all cosines, etc. And then you always want one side to be equal to 0. Okay, well, to get that first term, 2 cosine squared x, I gotta have a 2 cosine x and cosine x. I like this one because to get my last term of 1, it has to be 1 and 1. And what I really have to work on here is my signs. Because it's a negative 1, 1 is positive, 1 is negative. And I need to get a positive 1 cosine x. So think about your outside and your inside terms. You're going to have a 2 cosine x and a 1 cosine x. You want the 2 to be positive and the 1 to be negative. Set your factors equal to 0. We'll move fairly quickly through this. This is cosine x equals 1/2. We just did that one. That's pi thirds and 5 pi thirds. And then over here I will do cosine x plus 1 equals 0. So cosine x equals -1. Can anybody think of an angle that has a cosine of -1? Pi. Those are the only angles between 0 and 2 pi that work. Okay, we've got one other example to do. This one actually goes back more to like the basic solving from Friday until the end. So let's look at the equation 2 cosine of 4x equals -1. What's new and different about this one? There's a number on the inside. Before, all my other examples only had x's. So that number on the inside, that 4, you treat that like that's in a set of parentheses, like the cosine is protecting it. So you're gonna undo the 4 times x at the very end. I mean, obviously we're gonna at some point divide by 4 or multiply by 1/4, but that will happen at the very end. So for right now, I just treat it like Fridays and isolate my trig function. I'll get cosine of 4x all by itself. Divide by 2. Again, I can't do anything with this 4x because it's protected by cosine. I really have to undo the cosine first. What angles have cosines of -1/2? That cosine would be -√3/2. 2 pi over 3 in quadrant 2. And 4 pi over 3 in quadrant 3 because we're going left, right? And I left this blank over here. Normally I would write x equals, but now I'm going to write 4x equals. And, no joy here, check your directions. It just says solve the equation. So I want all the answers, right? So I would probably, after 2 pi thirds, I would do a plus 2 pi n, because these are cosines. They have original periods of 2 pi. So like everything's the same except for instead of saying x equals, I'm saying 4x equals because there was something trapped. It could be 2x, 3x, 4x, 5x. You just put that coefficient right there. Now we want to get x all by itself. So you might say divide by 4. Since I see a fraction on this other side, I'm going to say multiply by 1/4. That would just make it easier when I do the fraction work. But I just put a giant set of parentheses around my whole solution because I just need to multiply every single part of that by 1/4. So now I come out to get x equals, this would be like 2 pi over 12, but that reduces to pi over 6 plus 2 pi n over 4 pi over 2 and then do it on that bottom piece there as well, times 1/4. That's going to give me what? Pi thirds plus pi over 2n. Okay, now I want to take a little trip down memory lane about cosine graphs. Remember the parent graph of cosine had a period of 2 pi? Yeah? Okay, how did you find the period for any sine or cosine graph? 2 pi over b. And where was b in the equation? Right in front of the x. So if you're looking at our cosine of 4x, our b is 4, this doesn't actually have a period of 2 pi. It has a period of 2 pi over 4, which is pi halves. So notice in the answer, I shouldn't be adding 2 pi for those. I should be adding pi halves, because that's the period of cosine of 4x. But I don't really do it as 2 pi over b up here. I just multiply my whole solution by 1/4, and it'll take care of it for me. Okay. Now, before we wrap this up, I have one final thing to say, which can be a little bit confusing. So I'll make sure you're listening. If I change my directions on this problem, you have to be really careful anytime there's a different b value, anytime your period would be cut short. Because normally when I want to do this, like what if I want to find the solutions between 0 and 2 pi, I would just answer the question and I would say, you know, in this case when I divide by 1/4, I would say pi 6 and pi thirds. And like normally if the period was 2 pi, I'd never be able to add 2 pi and be less than 2 pi. But now my period is short, right? It's only pi halves. So can I take pi 6 and add a pi halves, which would be like 3 pi 6, and still be in between 0 and 2 pi? Yeah, I'd be at 4 pi 6, which is 2 pi thirds. And could I add another period? Yeah, because then I'd be at 7 pi 6. And could I add another period? 10 pi 6 plus 2 pi 6. 10 pi 6? Is that less than 2 pi? Yeah, it's 5 pi thirds. Can I add another 3 pi 6? And be between 2 pi? No, because 10 pi over 6 plus 3 pi over 6 would be 13 pi over 6. That's more than 2 pi. Okay. And then I would have to repeat the same thing for pi thirds. I'd probably change that one to 2 pi over 6 and add the pi halves as 3 pi over 6 common denominators. So I'm going to have the angles 5 pi over 6, what would be 4 pi over 3 and 11 pi over 6. You might notice here that we just listed all the pi over 3 and all the pi over 6 angles. So there would be a way to write that simpler up at the top, but I would guess you probably wouldn't. You would leave it alone as we have it. But if I were ever to ask between 0 and 2 pi, you really have to think about your shortened period. Can you actually add another thing and still be less than 0 or less than 2 pi? Okay? It's a weird one. You only have to worry about that if the directions say 1 revolution. Okay, here's your homework assignment. It's like 10-ish questions. I think it's less than that.